We're just talking about that notation, okay? So anytime you see this, what looks like an upside down N, that means and, okay? But like I said, the probability I think of the most are these two right here, all right? And then finally, the last thing we talked about was how to determine if things are independent, all right? So independent events, we have to check 3 probabilities, okay? And they have to all be equal. The probability of A has to equal the probability of A given B, which has to equal the probability of A given not B. Okay, so we do all 3 probabilities. If they're all 3 equal, then they are independent. Okay, so it's just the quickest way to check. Okay. All right, we're going to skip the examples that are on the back of this page. We're going to go to the ones that I made. We're going to do those 3, and then that's all we're going to do. All right, then we'll tinkle, and I'll get the laptops. Okay, so conditional probability always says given, all right? And then our independent events, all 3 of those have to be equal to one another. Okay. All righty, all right, all right. Okay. All right, we good? All right, rock and roll. So let's look at this one, okay? So we're talking about who rides snowmobiles in Yellowstone Park. Okay, so they tell me that N stands for never used a snowmobile. So N never used a snowmobile. And then E is the environmental club. Okay, and then S is a snowmobile owner. So you define those events for me. Okay, so the first one that they ask me to do is the probability of N given E. Okay, so what's the group that we're going to look at this time?
Yes on environmental.
Yes on environmental club. So let's find that in our chart. Yes on environmental club. And what's that total? 305. Okay, so 305 is going to be on the bottom. Now, out of those numbers, 3 numbers that we highlighted, okay, we want to choose the one that's N. N stands for never used a snowmobile. And so if I look at that list, how many of those 305 never used a snowmobile? 212. Okay, and then let's just get the decimal for that. 0.695. Okay. All right. And then let's talk about that last one. It says, given that the chosen person is not a snowmobile owner, what's the probability that he or she is an environmental club member? Okay, so it wants me to write. They put it in words. They want me to write this shorthand notation. Okay. So given that the chosen person is not a snowmobile owner, so I think we would say, what was that? S complement, right? Not a snowmobile owner. What's the probability that she is an environmental club member? So it's E given, not S, right? E given, not S. So my denominator is going to come from the people who are not snowmobile owners. Okay, so we're going to have to do some adding, right? So let's look. People that are not snowmobile owners. So that's my renters and my never used, right? And so if we look at those numbers, that would be what? 440, 657 and 574. We're doing our totals. Okay, so our totals for both of those people. So my denominator is 657 plus 574. So that's my big totals. Okay. Now, of those 2 lines, because sometimes I could have 2 lines in the chart, which I do with this one. Okay, never used and a renter. Which 2? okay? Or which numbers go with R in the environmental club?
212 and 77.
212 and 77. So we're going to add 212 plus 77. So we had to do a little math on that one. And that was just because we had multiple things going on. So it should give us 289 out of 1231, which I believe is 0.235. Okay, so that one's a little bit tricky. All right, so if you've got more than one category, sometimes you're going to have to do that. Okay. It's nice when it's just two things on each side, but this time I had three things. So that's why we ended up having to add, because they didn't match their requirement. Okay? All right, let's look at the next one. This one uses a Venn diagram. Okay, so this one uses a Venn diagram. And it says, what's the probability that a randomly selected resident who reads USA Today also reads the New York Times? So let's think about what that really means. Okay? I want the probability that a random who reads USA Today, so that would be given A, that they also read the New York Times. Okay, so A is USA Today, B is the New York Times. Okay, and they told me that up in the original thing. All right, so we're doing a Venn diagram for this one. Okay. So how many total people read the USA Today? Well, let's see. Yep, 40%, right? If they total read the USA Today, that would be the 0.35 and that 0.05. And so if I added them together, that's 0.40. Okay, so we added them, right? Now, out of that pink, how many of those pink ones also read the New York Times? That 0.05, because they're in the both category, right? And then we're going to divide those. Okay. So that would give me 0.125, right? So it works the same, all right? You find the smaller group, you find the group that you're talking about, and then the piece within that group, okay? All right, last one, we're going to be done. All right. So a Venn diagram representation. And then the last one, we go back to a chart, okay? And so it says, suppose that we choose one of the teachers in the sample at random. Are the events teaches math and left-handed independent? Okay. Well, let's start by just checking the the conditional probabilities. I couldn't think of the word, okay? So let's do the probability that we teach math and we're left-handed, given that we're left-handed. And then the probability that we teach math, given that we're not left-handed. Okay, so those are the two probabilities we're going to start with. We'd want to check it with the probability that I teach math, but we'll get there. Okay, so there are the three probabilities we want to check. Okay, so let's start with how many total people are left-handed? 10. Okay, of those 10, how many teach math? 7. Okay, which will give me 0.7. All right. Let's do the next one. How many people are not left-handed? That must mean they're right-handed. And of those, how many teach math? 39. Okay, and if I do that decimal, I get 0.5056. Okay, so do I even need to keep going? No, because those two things had to be equal. Okay, so because they're not equal, therefore not independent. And that's what we do. Okay. All righty. So you've got your assignment. I think it's 4 questions. Okay. Let me go grab some laptops and we'll tinkle while we're doing that.